Okay, let's talk about another design artifact called the control flow diagram. Sometimes confused with control flow graphs, and in fact, I often refer to them as control flow graphs as well, simply because the terminology is very similar. But there are actually two different kinds of charts: the control flow diagram and the control flow graph. This is the one that you're probably thinking of, with boxes that represent modules and diamonds that represent decision points and arrows representing flows and ovals representing control points. It's the one that most people are at least introduced earlier than a graduate course in software design. They'll see something like this. The other one, the control flow graph, is actually used primarily in testing. Okay, and we'll talk about it in a moment, but it's an artifact that if you came from a STEM background, you had a previous experience as an undergrad in a software engineering course or computer science course, you might hear control flow graph and think of something somewhat different than what this is. This is the simple control flow diagram. The purpose of a control flow diagram is to display all the conditions for control to flow from one module to another. Better thought of as like flow charts or something like that, because that's essentially what they are. Now, this is sometimes useful for identifying control couples, right? There's messages that would indicate there is some kind of control flow couple between two modules. And it is similar to interface structure diagrams in the sense that you're interested in watching the flow of control, but they're more intended to describe the flow of source code control rather than interface control, right? Program implementation flow. The same way that a data flow diagram is, from the purposes of a process standpoint, showing where data needs to go and how it would be processed once it gets there. That's the idea behind a control flow diagram. So here is an example of a control flow diagram. And you can see we've got a decision point here. This is the diamond decision point. And then we have these tasks and boxes. The actual arrows represent control flowing, which is why they're not labeled for single decision points. If control is currently in this box, there's only one option for it to go, and it goes out this one option. But for a decision point, there are two possibilities, and so we have to label those two possibilities. And you can represent iteration by simply having a flow that goes all the way back to the beginning. This is actually the starting point. Any unended arrow is the starting point in the control flow diagram. So in this particular case, we're deciding very early on if there is a new customer or not. And if there is a new customer, then we get the info from the customer and then we take their order. If there isn't, then we have to get their record of the existing customer from the database somewhere, and then we take their order. And that's essentially what's showing on this particular control flow diagram. So what is the control flow graph, the sort of computer science diagram, the testing diagram that you may have heard of if you had a STEM background? This is the thing that's displaying conditions required to move from one program statement to another, right? So somewhat different than moving from one module to another. And in this particular case, we use ovals to represent numbered statements, arrows to represent flow conditions, and again, primarily used for testing. So here's an example of a control flow graph. And this is not in the textbook. This is an example from Somerville's software engineering textbook. And I'm not actually going to require you to create or understand control flow graphs because testing is outside of the scope of this particular course. But I do want to show it to you, at least to demonstrate the difference between a control flow graph and a control flow diagram. Okay, the main reason that control flow graphs are used in testing is that they easily map to cyclomatic complexity. So if you're interested in trying to figure out all of the possible flows, all of the possible ways that the flow may go through program statements in a method, for example, or all of the expressions in a function or something like that, then you can actually calculate that using a control flow graph. So each statement is labeled with a node in the graph. So we've got, in this particular case, 9 total statements: 1, 2, 3, 4, 5, 6, 7, 8, and 9. And all we have to do is take the number of edges minus the number of nodes and add 2, and that gives us the total number of possible paths through a system. So in this particular case, the cyclomatic complexity is 4. And that's everything that we really wanted to talk about with the control flow graph. Mostly the purpose of this section in the textbook is to talk about control flow diagrams. These are very simple. You've almost certainly seen flowcharts before, and there's not much more to this than flowcharts, the main thing being that we're mapping specifically these nodes to parts of the system. right? The boxes are representing modules within the system, whereas in a traditional flowchart, they may not, right? It's a little bit looser in a traditional flowchart. But that's the entire idea behind the control flow diagrams as presented in the chapter.